Good morning, sir. My name is Mugilan. My matrix number is 23DBT20F2007. Today, I am going to explain about how to generate the scatter plot, correlation, and regression, linear regression equation, and much about the informations around the correlation and regression. So today, I am going to explain about the results part, which is the four questions and the discussions about the result. So, first and foremost, we're going to create a scatter plot to show the relationship between the calorie amount and amount of sodium, calorie category and amount of sodium mg. So, for that, we need the data. For the data, I go to the variable view, which is the calorie. Calorie is the calorie is the dependent variable and sodium is the independent variable. So for the calorie, the measure is scale, and for the sodium also its measure is scale. So for the calories category, so I just go to the transform and recode the different variable, and I choose the calories, and I just see, you could see the range over here. So they already given the ranges in the lab report. So the ranges over here. So the ranges are 100 until 139, 140 until 179, and 180 until 299. So put the range. So put the range in the recode section and just click OK. So afterwards I get the new calorie category. After that, you just it will be converted to the datas. Then another thing, you have to put the value for the calorie category, which is you have to put 1 and label as low, and 2 as a average, and 3 as a high. So now we already get the data all. So now I going to show how to uh, plot the scatter plot for the both graph. So they ask calorie and amount of sodium. For that, we have to go to the scatter plot section. So graph, chart builder, then choose the scatter dot and drag on the empty space and choose the sodium here, because x is the independent variable. So the sodium is our independent variable, and calorie is the y-axis, which is the dependent variable. Then just click OK. So now you could see the scatter plot over here. Then we also going to make another graph, another scatter dot, which is we're going to replace calories with the calories category. So now we already get the variable now. So now we're going to plot the scatter plot. So just click the OK one. So now we already get the simple scatter of the calories category by sodium. So this is the graph for the scatter plot for the calories category and for amount of sodium. So now the first question we already done. So now we're going to determine the correlation coefficient between calories and amount of sodium, and also calories category and amount of sodium. For that, we have to go to the section and analyze. we have the correlate. Choose the bivariate. For this, we have for the result I use Pearson, and for the test of significance I choose two-tailed, and the flag significance is the normal one. So choose calorie and sodium first. So then click the OK. So now we already get the Pearson coloration. The coloration is 0.887. So you could see here. Then we also going to see the another correlation, which is the calories category. So for that I just remove the both. First I put calories category and sodium. So I just click OK. Now we get the correlation for the calories category. For the calories categories we get 0.847. So this is the way to get the correlation. Then let's we move to the third question. Obtain the regression equation to show the relationship between calories and amount of sodium. So for this we have to go to the uh, regression and choose linear. For the dependent is the calorie. I choose calorie, and for the independent is the sodium. So now I just going to click OK. Now we already get the regression for tables. So the R is the coefficient. So for regression we already get the four tables, which is the variable and model summary, ANOVA, and coefficient. For the coefficient, R is the coefficient. So the coefficient for our data is 0.887, and the R2 is 0.787. So at the coefficient area, so we could see the sodium is the because we have one equation, which is the M equals to mx plus c. C is the intercept of the data. So the constant, which is the 78.192, is the intercept, y-intercept. So the sodium is the M. So for that the equation would be like this. So the equation is y equals to 78.919 plus 0.19x. So the mx, so the m is 0.196. Then for c is 78.19. So the for 2 we don't need lah, we just use 2 decimal points. Okay, so then for last we're going to plot the regression line on the scatter plot of the part A. For that we have to go to this one and choose the first graph, not this one, the first graph, and click twice so we can see we get the editing side. So just click here so we can get the scatter line, right? Regression line, sorry, the regression line. So this is the regression line. So then this is the equation that we get before. Okay, yes. So now just click this one. So now you could see that this is the regression line, and this is the linear regression equation of our data. So let's we move to the discussion part. So now I just going to read the discussion that I wrote for the data regression. From the scatter plot, we could conclude that the relationship between the two variables is direct positive relationship. Yes, there is linear correlation in scatter plot. The correlation is positive. I agree with the correlation coefficient produced in the computer output because the actual correlation is same with the computer generated correlation. The value of the coefficient is 0.887. The R2 value is 0.78, which is indicates the total variation of the calories that can be explained by amount of sodium. The regression equation for the sample data is y equals to 78.19 plus 0.2x. The slope indicates that the relationship between the two variables is positive. So this is the discussion that we could make from the results. So thank you, sir.